Hello my friend, this is SHYSKY Tech. In this video, we will talk about this micro brushless DC water pump of SHYSKY series, this model DC55E-24160S model. This is a 24 volts, 80 watts micro brushless DC water or pressure circulation pump. Yeah, working at 24 volts DC. And this pump is equipped with dry run protection mechanism. Okay, this is the pump body, control box, the power cord, DC head. Okay, I record this video to briefly introduce the pump's performance, its characteristics, its protection mechanism, and I build a simple water pumping test bench. Yeah. In 1 bucket of water, the pump itself, and this a stable DC power supply offering DC 24 volts power supply. As we can see, 24 volts. Yeah, this is the working current indicator, this is the power consumption indicator, and this is voltage indicator. Okay, regarding this pump, let me briefly introduce some information. Model name, our DC55E-24160S model, and the power supply must be powerful enough. It can be the DC battery, or sometimes solar panel, or perhaps most commonly used the AC-DC power adapter. Yeah, if it is the AC-DC power adapter that is used to power this pump, the output capacity of this adapter should be 24 volts DC, and the working current, the current capacity should be 4 amps or over. We can make a simple multiply, 24 volts multiply 4 amps, 96 watts. And this pump rated working current, working power, 80 watts. So it should be 24 volts, 4 amps, or even 5 amps, 6 amps, or even 8 amps. Okay. Otherwise, the power supply could be less powerful than needed to power the pump. Okay. Then about the pump, it is with dry run protection mechanism that is integrated in default. Yeah. Our pump cannot be self-priming. I will introduce a bit later. First, this is the pump body part. This is removable connector. And this is the control box part, and this is power cord, DC head. Yeah. Inside positive, outside negative. Regarding the control box part, rectangle shaped, metal protected. Yeah. It is the brain part to the whole pumping system. We can call it brain. Yeah, brain part, because the main control and protect circuits are integrated with it. When installation, this part is not recommended to be placed on the water, but instead placed at somewhat lower temperature and with dry location. Okay, this is the pump body part, and as we can see, this is inlet, this is outlet. Both ports are half-inch threaded with external diameter about 2 centimeters. Inlet, outlet, yeah. And we can see inside the pump cavity there is this rotor part. Yeah. Actually, the pump works by the high-speed rotation of impeller within the cavity to push the water inflow out of the outlet, achieving the performance of water circulation. Our pump cannot be self-priming. Namely, if the pump is located here, and if we want to collect a pipe to want to suck the water from lower location to higher, this is what this pump cannot do. It is because it is not designed for this type of job. Yeah. Instead, this pump can work on the water, placed on the water. Yeah. Or it can be connected with external pipe, but make sure that the water can actively flow into the inlet and the pump pushes out. So either land use with pipe connection, but make sure that the water level is higher than the pump body's location, and then the pipe can connect here, the water can actively flow into the inlet. Or the pump itself is completely submerged underwater. So these are two typical installation ways. Okay. Then let's talk about the dry run. Okay, since our pump cannot be self-priming, so that when there exists insufficient or even zero water inflow into the pump's cavity, the pump's rotor part will rotate with air or partially with air. And in this context, the physical friction will be sharply intensified and the heat generation will be sharply intensified. And this will absolutely negative to the pump's physical composition and the pump's reliability. For example, if it happens that our pump dry run lasting for over 1 to 2 hours, this pump body could be completely dead. Yeah, it happens if in this extreme abnormal working scenario. So we can see when we as users hear or feel the louder, the sharper noise when the pump works, and when we feel that the water flow outflow turns weak and discontinuous, then we can confidently judge that this pump is now in dry run status, and the dry run protection of the pump will automatically take effect. Okay, so after introducing so much, let's do this test. Okay, power the pump. Okay, this pump is now in dry run status, of course, and we will connect the power connection. Okay, pump is in dry run status, but the pump will automatically trigger its protection mechanism, so it will stop for a short while. The sharper, louder noise happens. So we trust that the louder noise must happen only in this context. Okay, since it is water pump, so we will place it on the water to simulate the circulation system. Okay, the pump will recover back to normal continuous running with no noise, right? And we can see the parameter of this pump. The working current about 3.6 amps. The working power consumption at this moment is about 86 watts, and the rated voltage 24 volts DC. We can feel the noise turns rather low, right? Yeah. Okay, we get this pump out and let it dry run. We will feel this dry run. This is abnormal scenario, but we just display this abnormal scenario. The noise is louder, and if we as users to look at from the output, we will feel that the water flow will be discontinuous, will be weak, sharper, louder noise. And in this context, we place it on the water again to see what it will happen. Okay. Sufficient water inflow into the cavity of the pump, and the pump will push or through the water out of the outlet, achieving the performance of water pumping. This is important. Yeah. Either this pump is submergibly installed like this way, like what I now test, or the pump could be connected with the external hose, with external pipes on both ports. Yeah. We feel the dry run again. Dry run protection is automatically triggered. As we can see, the power also is very weak at this moment. Okay, we place it on the water again. Typically, seconds delay happens. let me talk about when the pump is dry run status. We should figure out why this system causes the insufficient water flow into inlet. Sometimes when the water source is with quite insignificant high level, or when the pipe connection to the inlet is very slimmer when compared with the pump's inlet part, or the pipes is just twisted, very long. In all those contexts, the water flow into the pump may be weaker when compared with the real output of the pump, and then dry run happens. Yeah. And sometimes when the pump is not fixed, it will run, and then water flow will also be insufficient. This is the introduction about this DC55E-24160S pump model. The working and the dry run protection, and also other points. And thank you for your time. The dry run protection, 0.3 watts when it is triggered. And thank you. Let's place the pump into normal work again. This is the normal work. And thank you for your time.